Back on Wikipedia, we can see that level 3 own network 4 and network 8. AT&T own network 12. Now I allocated autonomous system 8 and 4 in this topology, so let's for the moment pretend that AT&T own autonomous system 4 and addressing structure 4, and a level 3 own autonomous system 8 and network 8. Here we've got another autonomous system 20. So let's build this network where we have Apple running within this enterprise, connecting to our pretend level 3 autonomous system and our pretend AT&T autonomous system. So these are two ISPs which in turn connect us to a fourth autonomous system 20. Notice this link is in network 8. In other words, it's using addresses from level 3. This network is using addresses in the 4 range from our AT&T network in this topology. But internally, the network is using addresses in the Apple range. I've configured the IP addresses in this topology, but I've not configured any routing protocols. So on router 1 as an example, show IP route shows us that we only have directly connected networks in the routing table. Show IP protocol shows us that no protocols are enabled on this router. So let's enable BGP. So conft router, and in this example we're going to choose BGP, and we need to specify an autonomous system number. In this case it's going to be 17. BGP uses neighbor relationships for a lot of the configuration and filtering options. So if you wanted to filter a route, in other words, not advertise it to another autonomous system, you would do your configuration on a neighbor or a peer. So we're going to use the command neighbor, and we're going to specify a neighboring router. Now there are two BGP routing protocols. You have iBGP or internal BGP or interior BGP, and then you have eBGP, external or exterior BGP. This relationship from router 1 to router 2 is going to be configured as an internal BGP relationship or iBGP relationship because they're in the same autonomous system. The relationship from router 2 to router 3, however, is going to be configured as an eBGP relationship because they are in external autonomous systems. Router 2 is in a different autonomous system to router 3. In the same way, router 2 and router 4 are going to be configured with external BGP relationships, whereas router 3 and router 5 are going to use iBGP, router 4 and router 6 are going to use iBGP, and 6 to 7 and 5 to 7 are going to use eBGP. When configuring iBGP relationships, it's typically good practice to use loopbacks for the neighbor relationship. Router 1 has this IP address as a loopback, and router 2 has this IP address as a loopback. Loopbacks provide redundancy. So if we had multiple links between router 1 and router 2, and one of those links went down, we would still have IP connectivity between the loopbacks. So it's good practice to use a loopback interface. So on router 1, we've started configuring a neighbor relationship to router 2. So we said neighbor IP address of the loopback ? That gives us a lot of options, but the option that we're interested in is remote AS or remote autonomous system. Now, even though these are configured as iBGP peers or iBGP neighbors, in other words, they are in the same autonomous system, we still use the remote AS command. So we're going to specify neighbor, the neighbor's IP address, remote autonomous system, the autonomous system number, and then press carriage return. Show IP BGP summary will show us a good amount of information in summary format. We can see the router has a router ID of 17.17.17.1, which is the loopback interface. In this case, a loopback 0. This is similar in concept to a router ID in EIGRP or OSPF. The local autonomous system is 17. BGP table version number is 1. We haven't had any changes in the BGP table at the moment. And notice we have a neighbor relationship using BGP version 4 to Autonomous System 17. No messages have been sent or received. The relationship has never been up or down, and the state shows active. This is very misleading. Active in BGP doesn't mean that it's working. Active actually means that a TCP connection has been completed, but no BGP messages have been sent yet. So BGP has these states. Idle means that there's no connection to the neighbor, so you might have disabled the neighbor by shutting it down. Connect means that a TCP connection has been attempted, but hasn't been completed. Show TCP brief as an example shows us that we have no TCP sessions currently up on the router. BGP is a layer 7 protocol and relies on TCP in the same way that Telnet relies on TCP. So if I try and Telnet to 17.17.2, notice the destination is unreachable. Router 1 has no connectivity to the loopback of router 2. We need to enable a IGP, in other words, an interior gateway protocol, such as OSPF or EIGRP, within our autonomous system to allow this router to form a TCP session to router 2, and in turn to allow router 2 to form a TCP session to router 1. Before we do that, let's summarize the BGP neighbor relationship states. We have idle once again, where the neighbor is shut down. We have connect, where the TCP connection is attempted but hasn't been completed. Active means that the TCP session has completed but no BGP messages have been sent. Typically, active means that you have IP connectivity to the neighboring device. Open sent, the TCP connection exists, and this router is trying to create a connection to the neighboring device. One of the BGP routers will initiate a connection to the neighbor using open sent. And open confirm means that the TCP connection exists and the local router has received a message back from the neighboring router. However, the neighboring router may reject the relationship. BGP relationships are not automatically configured. You have to manually configure both sides of the relationship. Just because I want to be your neighbor, it doesn't mean that you want to be my neighbor. There's certain kinds of establishments you might not want to live next to, such as a nightclub or some kind of establishment where they play loud music to the early hours of the morning. In the same way, in BGP, because we're having connections made between different companies or different autonomous systems, both sides have to agree to form the neighbor relationship, and I'll demonstrate that in a moment. Establish is what we're looking for. That means that both routers, in other words, neighbors or peers, have agreed to form a relationship, and the relationship is now established or set up, and they can exchange BGP messages with each other.